Bismillahirrahmanirrahim. I welcome class 10th in my lecture series for chemistry. We are on chapter 12, that is hydrocarbons, and our topic for today is the electron dot cross structures of alkanes. So before moving forward, let's discuss or let's revise certain features of the alkanes. These alkanes are called as the saturated hydrocarbons. This means that all the carbon-carbon bonds in the alkanes is a single bond. They are made up of two elements, carbon and hydrogen. And the general formula for alkane is CnH2n plus 2. Here n represents the number of carbon atoms. So before moving forward, let's discuss the position of these two elements, carbon and hydrogen, in periodic table and their valency. We know that the carbon belongs to the group 4 of the periodic table, and you must have read it in your 9th class chemistry books that the group number basically represents the number of valence electrons, number of electrons in the outermost shell. So if an element is present in a group 4, then this means that the number of valence electron would also be 4 in that specific atom. So since carbon belongs to group 4, it has 4 electrons in its outermost orbit. Therefore, its valency is also 4. By valency, I mean that the carbon forms 4 bonds. Carbon is a non-metal. Here is the electronic configuration chart for carbon atom. We must have read about the electronic configuration in your 9th class chemistry book. Let's revise that how the electronic configuration of carbon atom is written here. We know that the s orbital holds up to 2 electrons, p holds up to 6 electrons, and d holds up to 10 electrons. So by following the 3 rules of Power principle, Pauli's-Dirichlet principle, and Hund's rule, we will write the electronic configuration for carbon atom. We know that the atomic number for carbon atom is 6. So first we will fill the 1s orbital, and we know that since s orbital can only accommodate 2 electrons, so we will fill first the 1s with 2 electrons. Then we will move towards the second shell. In the second shell we have 2 orbitals, 2s and 2p, filling the 2s orbital by 2 electrons. Then we will move forward to another orbital, that is the 2p, and this 2p will also contain 2 electrons. So if you count the total number of electrons, 2 plus 2 plus 2, that becomes equals to 6. So this is the electronic configuration for carbon atom, 1s2, 2s2, 2p2. Now this second shell is the valence shell for a carbon atom, and through this electronic configuration you may observe that this valence shell is containing 4 electrons. Now what carbon does, that by using these 4 electrons, it shares these 4 electrons with other atoms to form 4 covalent bond, and after the formation of covalent bond, it tries to complete its octet. And when it tries to complete its octet, it becomes stable. We know that the every atom or every element tries to make bonds in order to complete its octet, because when an octet of an atom is completed, it achieves its nearest noble gas electronic configuration, and when that electronic configuration is achieved, then the atom or the element becomes stable. So all the atoms usually form bond in order to get that stability. So the position of carbon atom in the periodic table is 4a, and by writing the electronic configuration, we may draw the structure of carbon atom like this. We know in the middle there is a nucleus of carbon atom, and this nucleus contains 6 protons and 6 neutrons, and the total electrons of the carbon atom is 6. First shell contains 2 electrons, and the outermost shell, that is the valence shell, contains 4 electrons. The atomic number of carbon atom is 6. Its electronic arrangement is 2 4. This means that in the first shell 2 electrons are present, in the second shell 4 electrons are present. So since there are 4 electrons in the valence shell or outermost shell, it has 4 valence electrons. It can attain stability by gaining 4 electron, losing 4 electron, or sharing 4 electrons with other atoms. These are the conditions with which it can get stability. Either it can take 4 electrons from any outside source, from any other element, or it can lose its 4 electron. When it will lose its 4 electron, then it will be left only with the one shell, one s shell, and that is filled. So it can also get stability by losing 4 electron, or it can get stability by sharing 4 electrons with other atoms. Out of these 3 conditions, only the condition of sharing of electron is possible for carbon atom. The carbon atom does not gain 4 electrons because it is difficult for the 6 protons to hold 10 electrons. Here you may see that this is the structure for carbon atom. In the nucleus, how many protons are present? 6, and these 6 protons are holding 6 electrons. When if a carbon atom gets 4 electrons from an outside source, then the number of electrons becomes 10. So then it will be difficult for this 6 protons to hold those 10 electrons. So this condition of gaining 4 electrons gets ruled out. Now let's discuss about losing 4 electrons. Carbon atom does not lose 4 electrons because it needs a large amount of energy to lose 4 electrons. So the second condition also gets ruled out. So we are left with the third condition, that the carbon atom shares 4 electrons with other atoms to attain stability, resulting in the formation of covalent bonds. We know that the covalent bonds are formed by the mutual sharing of electron. So carbon atom, instead of losing electrons or instead of gaining electrons, finds it more suitable to share its 4 electron in order to complete its octet. Now, since carbon atom needs 4 electrons to attain stability, its valency is 4, and therefore it is also called as tetravalent. By tetra means 4. So this means that carbon forms 4 bond. You have to remember or memorize it, that carbon forms 4 bond. So you may represent the electrons of the carbon atom like the crosses as drawn here, or you may represent the bonds of carbon atom as the dashed lines as represented here. First, look at the position of hydrogen atom in the periodic table. In the periodic table, hydrogen is present in 1a group. So this means that there is only one electron in its outermost shell. If you look at the atomic number for hydrogen is 1. So this means that this atom contains only one proton and one electron. This is how the atomic structure for hydrogen atom is drawn. You may see here that one proton is present in the nucleus, and outside the nucleus one electron is present in the electronic shell or the valence shell. Now if you write the electronic configuration for the hydrogen atom, you will write it as 1s1. So since s orbital can accommodate 2 electrons, so this means that this 1s orbital is not completely filled, it is partially filled, and it needs one more electron to complete this orbital in order to achieve its nearest noble gas electronic configuration. So hydrogen atom will share this one electron with any other atom in order to complete its orbital. So this means, since the electronic configuration for hydrogen is 1s1, so this means that hydrogen atom can only form one bond. Carbon atom can form 4 bonds and hydrogen atom can form only one covalent bond. So now let's move towards the drawing the electron dot and cross structure for alkanes. Alkanes, the simplest alkane is the methane, and which is the main component of the natural gas. For the methane, CH4 is its molecular formula, and the structure formula for methane is drawn as drawn here. What is a structure formula? A structure formula is like a Lewis structure, but it typically depicts the bonding electron pair as dashes and omits the lone pair. What are lone pair? Lone pair are basically the non-bonding electrons. Here these lines are representing the bonding electrons. So let's draw the electron dot and cross structure for methane. In order to draw this structure, first we will draw the carbon atom and we will draw 4 electrons. We will arrange 4 electrons around this carbon atom. Now we know that since it contains 4 electrons in its valence shell, therefore it will share these 4 electrons with any other atom to complete its octet. Methane is a hydrocarbon, so therefore other element would be a hydrogen atom. Now in a hydrogen atom only one electron is present in its outermost shell. We will be representing the valence electron of hydrogen atom with the cross. So let me change the color. Now I am just arranging hydrogen atoms around the carbon atom. So this is how the electron dot and cross structure for methane is drawn. Now if you look at the number of electrons in the valence shell now, then you may easily calculate it as 4 electrons are of the carbon itself plus 4 hydrogen atoms shared 1 electron with the carbon atom, and the total number of electrons become 8 in the valence shell of the carbon atom. So this means that the octet for carbon atom is complete. We know that when the octet is complete, so this means that carbon has attained stability. Similarly, if you look for hydrogen atom, one electron was present in its outermost shell, and hydrogen atom shared this electron with 1 electron of the carbon atom. So the total number of electrons in the valence shell of the hydrogen atom becomes 2. So this means that the outermost or the valence shell for carbon and hydrogen both are complete now and both are stable. Now let's draw the electron dot and cross structure of ethane. We will first draw the carbon atom. Now since it is ethane, this prefix eth is representing 2 carbon atoms. So we will draw 2 carbon atoms in a row, or you may write it as like this. Draw dots around the carbon atom. These dots are representing the electrons of the carbon atom. Now if you look at it here, this electron is being shared with another electron of the carbon atom. So we are left with 3 electrons on both sides of the carbon atom. So now we will draw the electrons of the hydrogen atom, and we will represent the electrons of the hydrogen atom with a cross. Now we will just arrange the hydrogen atom around each carbon atom. So this is the electron dot and the cross structure for ethane. Now if you look at the carbon as well as all the hydrogen atoms, you will see that the outermost shell of each atom is complete, and therefore all the elements get stability because of the complete valence shell. Now let's practice drawing the electron dot and cross structure of propane. Now the prefix prop is representing here that the 3 number of carbon atoms are present in this organic compound. So we will first write 3 carbon atoms in a row, and then we will draw 4 electrons around each carbon atom. Here this green dot is representing the valence electron of each carbon atom. Now for carbon number, let me number the carbon atom. Now for carbon number 1, one of the electron is being shared with another electron of the carbon atom. This carbon number 1 has still 3 unpaired electron, so it will share these electrons with the hydrogen atoms in order to complete its octet. Now for the second carbon atom, 2 electrons of the second carbon atom is being shared with 2 other carbon atoms. So second carbon atoms contain 2 unpaired electron. So these unpaired electron will be shared with the 2 hydrogen atom in order to complete the octet of the second carbon atom. For third carbon atom, only 1 electron is being shared with the another carbon atom. 3 electrons are unpaired, so these unpaired electron will be shared with the hydrogen atoms. So if you look at the valence shell for each of these atoms, you will see that the valence shell for all these atoms has been completed. So this is how electron, dot and cross structure for alkanes is represented or drawn. You have to practice drawing this electron, dot and cross structure for the higher alkanes. This was all for today, and we will discuss our next topic in our upcoming lecture. Thank you for being with me.